Hello and welcome to Devaney's World of Maths. This is dealing with Algebra 1, order of operations and evaluating expressions. And before we start talking about the ideas of order of operations and evaluating expressions, which are two valuable ideas for algebra, we will be talking about the vocab, which we're dealing with the vocab words power, exponent, base, simplify, and evaluate. So first, let's take a look at the word power, exponent, and base. All right, so the big one is power, exponent, and base. Okay, so when we're talking about this, if we were to talk about it in terms of word phrase, we would say raised to the third power. Okay, oops, and I misspelled that. There we go, fixed it. Raised 2 to the third power. And so when we're talking about power and exponent are kind of interchangeable. This is called the exponent, this little number up here. This will tell you how many times we want to multiply 2 together to represent an actual power number. Okay, so power and exponent, it depends. You do have to change your vocab a little bit if you use one or the other, but it does work the same way together. One of the earliest proponents of powers and exponents was one of the, I can't remember if it was Vincent Tartaglia or if it was one of his relatives, but they all have the last name of Tartaglia, and they're Renaissance mathematicians, and they actually talked about the idea of representing something that is one of the earliest people to actually do this was to represent this as this repeated multiplication as an exponent version. Okay, now today we also know it as some computer notation, which is we have this little caret character, and if you ever need to know how to do that, you would press Shift and 6. To represent it this way is to raise to the third power. You would have to type a 2 and then type a little bit above it and type a 3. The computer shortcut for that for the keyboard is a little bit harder to put in, so I don't like to use it as much, but I like to use the computer scientist way to actually represent this. Now the next word is simplifying or simplification. In other words, simplification is we would actually take our numerical expression and we would actually simplify by performing the actual operation. So for example, with 2 to the third, you can rewrite it as 2 times 2 times 2, and I would write it as its actual answer, which is 2 times 2 times 2, which is actually going to be 8. Okay? All right, now this leads us into our next idea, which is talking about the ideas of evaluating. Now, evaluate is one of the most important ideas in algebra that we're ever going to deal with, because what it basically says is take an equation or an expression and you take whatever the variable is and you pick it. We all know that it's going to be a placeholder, but we now know what that placeholder represents. So what we are going to do is we're going to substitute for every single x in this problem. We are going to substitute in x3 for it. So we see an x here, we replace that with a 3. We see an x here, we replace that with a 3 to get this. Now some students would be tempted to rewrite it as 73, but remember, when a number, a quantity, and a variable are right next to each other, the operation between them is multiplication. Okay? Now, this goes into the next part. Evaluation is we are substituting in 3 for every x in our expression. How do we actually solve this? So this is where order of operations comes into play. All right, so what you're going to do is you're actually going to follow these orders. Now, to be honest, these ideas actually come from the fact that mathematics is what is called a binary science. In other words, we do two things. We work with two numbers at a time, we perform an operation, and then we simplify it, and we continue to simplify down until we get one number. Okay, so technically you could put grouping symbols around everything. There's actually a great video on this. I think it's on Minute Physics, which they talk about order of operations and how it's wrong. It's not wrong, and you just want to be careful about what you're thinking about with this type of stuff. So for example, like this, why this 3 to the 4th minus 7 times 3, you can actually rewrite it like this and understand why we are going to follow the order of our operations the way it is. Okay, So I basically wrote it out in long form. 3 to the 4th is 3 times 3 times 3 times 3, 4 times basically. And then 7 times 3 is going to be 7 3's added together. Okay, so as you can see, I don't want to mess with those and rearrange them however order I want, because this is actually what it represents. These are just shortcuts. The stuff on the left is shortcuts for the stuff on the right. Okay, all right. Now, when I simplify them, calculators are totally allowable. Don't feel like ashamed if you're using a calculator for these ideas and stuff. So like, for example, the first one would be 81 if you put in the calculator, and then the second one would be 21, so that you can re-represent it like this. So we basically performed any operation inside the grouping symbols. We didn't have any, so we didn't do that. We did simplify the powers. Okay, so that worked out. And then we multiplied from left to right, so we did multiply. Okay, and we did multiply this, and we ended up multiplying these to make sure that we understood them as well. Okay, just wanted to make sure that I clean that up a little bit so that we're not confused as to where to go. Okay, so we multiplied from left to right, and now we just go ahead and deal with the adding and subtracting from left to right. And so all we have left is 81 minus 21, which is just going to be a plain old 60. You can use your calculator at home to check the work to make sure it's done correctly. All right, now these are two different types of problems, and I'll talk about each one in its order. For example, this first one, 4 plus 2 to the 4th over 7 minus 2. Now, if you remember on the last slide, we had the instructions of the order of operations, and I'll bring them up again. All right, so we perform any operation inside grouping symbols. Now, a fraction bar can act as a grouping symbol. So what I'm going to do is I'm going to rewrite it with the grouping symbols that it's intended for. Okay. All right, and so what we have is on the top we have 4 plus 2 to the 4th in parentheses, and on the bottom we have 7 minus 2. Okay, now let's go ahead and perform any operations inside those grouping symbols, starting with the powers first and just working our way across. Simple. So what I would do is I would deal with the 2 to the 4th, and now it would become 16 because it's 2 times 2 times 2 times 2. And then on the bottom I would have 7 minus 2, which would become the 5. Now if I simplify it even further, I should get 20 divided by 5, which is going to turn into 4. Because once again, I go ahead and perform the operations. I finish up here with the grouping symbol, and now all I have left is division. So as a matter of fact, I did do these first 3, and then I did do a little bit of addition because I was working with these two numbers up here. Okay. All right, now let's talk about evaluating expressions, especially the one on the right. Now the nice thing about evaluating expressions is that we can actually take this, and let me move it up a little bit. What is the value of the expression if x is equal to 5 and y is equal to 2? You can actually solve several or simplify several different ideas just based upon some initial conditions of, okay, this variable, which is a placeholder, once again, if we remember, x and y aren't actual numbers until we say they are, so they're just placeholders. Okay, so right now we're going to say those placeholders are going to be the value of 5 and 2 respectively for x and y. And let's start simplifying the first one. X squared plus x minus 12 over y squared. Let's go ahead, and the first step is to go ahead and substitute our values of x and y, our placeholders. Let's substitute in the actual values for those placeholders. All right, now I went ahead for x squared. I replaced it with a 5, so now I've got a 5 squared. I replaced this x with a 5. Nothing's really done to it, so we're going to leave it be. Now some people might be tempted to go 5 minus 12, but remember the first step is you just substituting. Just substitute, and then you do your order of operations, okay? All right, now the first thing we're going to do is perform any grouping operations. Nothing in there, so we're going to go ahead and simplify the powers. There's only 2 powers, so we're going to rewrite it real fast. We're going to rewrite it real fast as 25 plus 5 minus 12 over 4. Now, some of you guys are going to be tempted to go, oh, 25 plus 5. Just wait a sec, slow down a little bit, because we want to make sure we do this correctly. Because we want to do multiplication before we do any addition. Okay, so what we're going to do first is multiply from left to right. This is add, so we don't do anything. This is also subtract, so we don't do anything. But this is division, so let's go ahead and do something. And here's what we get. All right, so now we get 25 plus 5 minus 3, because 12 divided by 4 is going to be 3. All right, now we can go ahead and do the operations. We can actually simplify this all the way down to its final answer. 25 plus 5 is 30, minus 3 is going to be 27. Okay. Now, what happens if you accidentally go 5 minus 3 first? It's not going to be the end of the world, but it's very bad practice, because what if this was a minus here in front of this 5, and you go 5 minus 3? Well, you should treat it as a negative. So if there's a negative here, it's just best to just go from left to right and not try to mix them up. Okay, otherwise you get yourself into some trouble and you're like, oh, what happened? Why did I mess up on my test? And that's why, is because you just went too fast. Okay, now let's start on the next one, x times y raised to the second power, and let's go ahead and evaluate by substituting in the values of x and y. We get 5 times 2 squared. What do we do first? Do we do the exponent, or do we just do the stuff inside the parentheses? Once again, just following the rules of PEMDAS, parentheses first. So what we're going to do is we're going to simplify the stuff inside the parentheses. And we are going to get 10 squared. Okay, now we can actually do the exponent. And the exponent is going to tell us to go 10 times 10, which is 100. Don't accidentally do 220, because that just means that you're multiplying 10 by 2. And we've got 10 squared, which represents 10 times 10. All right, that is it for talking about evaluations of expressions and also order of operations. I hope you have a wonderful day, and I'll see you back here later.